Okay. In this problem, we're going to find the first four terms in general terms for 1 over x at a equals 2. Okay. So again, I always like to just write down my Taylor series formula here. Get the nth derivative evaluated at a over n factorial, and then x minus a to the nth. In our case, a is 2. We start at 0. Zero derivative, remember, is just the function. Okay, so the function is 1 over x. Maybe easier to write it as x to the negative first. Derivative be negative 1, x to the negative second. Second derivative, 2x to the negative third. Third derivative. Now, I was asked for 4 terms. This should do it, right? I have 4 down. Nothing's going to cancel out and be 0. So this should do it. Okay. Let's simplify these a little bit. Let's put them into fractions. So 1 over x, negative 1 over x squared, 2 over x cubed, negative 6 over x to the fourth. So we're going to have an alternating series here. Now we're going to evaluate these at 2. So 1/2, negative 1/4. Now 2 over 2 cubed, so 2 over 8, that's positive 1/4. 6 over 2 to the fourth, 2 to the fourth is 16, so this is negative 3/8. Okay, this doesn't look like a real nice pattern, so we're gonna have to see here what happens. Let's start by writing our 4 terms out. So the derivative's value is 1/2. I put that over 0 factorial, and I have x minus 2 to the 0 power. And I've got negative 1/4 over 1 factorial, x minus 2 to the first. I've got positive 1/4 over 2 factorial, x minus 2 squared. Then I've got negative 3/8 over 3 factorial, and x minus 2 cubed. Okay, let's simplify. First term will just be 1/2. Then we'll have minus 1/4 times x minus 2. Please remember that this is the tangent line. A tangent line is just a Taylor series, Taylor polynomial, with just going out to the first power. Now, 1/4 divided by 2 factorial, that's like 1/4 divided by 1/4 divided by 2, that's 1/8. Three-eighths divided by 3 factorial, so 3/8 divided by 6, that's 3/48, which reduces to 1/16. There are my first 4 terms. Now, the general term. Well, I see that it's alternating. I'm gonna put the general term up here. I see it's alternating, so it's got to have a negative 1 to the nth. The first term is positive, so it better be in like minus 1 or something. Of course, every term has an x. Looks like every coefficient numerator is going to be 1, so we could have 1. Every term is going to have that x minus 2 to the nth power in it. The bottom, you'll see it just went 2, 4, 8, 16. So it's the evens. I'm sorry, it's 2 to an nth power. 2 times 2 times 2. It's not just evens, it's powers of 2. So we got 2 to the nth power. Now let's just see, if I start at 0, 2 to the 0 is 1, so I better change this a little bit. I better make it like plus 1 right here. So again, the general term is sometimes hard to come up with. The basic idea, I guess I'd start with the fact that it was alternating, and I wanted to make the first term positive, so I changed that a little bit. Every single term was going to have an x minus 2 to a power in it, so x minus 2 to the nth. And every numerator was 1, came out to be 1. The denominators, you got to look for a pattern here. And it came out to be 2 to the nth. But if I start at 0, which the Taylor series typically does, 2 to the 0 is 1. Well, the first term should have a 2 in it, so I made it n plus 1. And that's it. That's our general term for this series.